Students, the next question is pH of 0.1 molar solution is in the order. So your options are NaCl less than NH4Cl less than NaCN less than HCl. Option B, HCl less than NH4Cl less than NaCl less than NaCN. Option C, NaCN less than NH4Cl less than NaCl less than HCl. Option D, HCl less than NaCl less than NaCN less than ammonium chloride. Your options are option A, sodium chloride less than ammonium chloride less than sodium cyanide less than HCl. Option B is HCl less than ammonium chloride less than sodium chloride less than sodium cyanide. Option C is sodium cyanide less than ammonium chloride less than sodium chloride less than HCl. Option D is HCl less than sodium chloride less than sodium cyanide less than ammonium chloride. Now, so these are the salts, and the aqueous solution will be acidic or basic depending upon the type of salt it is. If it is a salt of strong acid and a weak base, then it will be acidic. If it is a salt of strong base and weak acid, it will be basic. Salts of strong acid, strong bases will be neutral, whereas salts of weak acid and weak bases, you cannot predict the pH, but you can calculate the pH of the solution. Let us try to analyze this based on the concept. Now, the sodium chloride is given. Sodium chloride on hydrolysis, if you prepare a solution of it, you get NaOH plus HCl. NaOH is a strong base, HCl is a strong acid, they undergo complete dissociation, hence H plus ion concentration will be equal to OH minus ion concentration, hence pH of this solution will be equal to 7. The next given is ammonium chloride. Ammonium chloride on hydrolysis, when you treat ammonium chloride with water, you get ammonium hydroxide plus HCl. HCl is a strong acid and ammonium hydroxide is a weak base. So here the concentration of H plus will be greater than OH minus because HCl undergoes complete dissociation and the solution will be acidic. If solution is acidic, the pH will be less than 7. The next given is sodium cyanide. Sodium cyanide, when treated with water, it forms NaOH and HCN. HCN is a weak acid. NaOH is a strong base, hence the solution will be basic in nature because this undergoes complete dissociation, whereas this undergoes partial dissociation. Solution will be basic. If the solution is basic, pH will be greater than 7. The next one given is HCl. HCl is a strong acid which undergoes complete dissociation and pH will be less than 7. So the one with least pH value is HCl. Next comes ammonium chloride, next comes NaCl, and next comes NaCN. Hence, option B is the right answer. Concept of acid and a base. According to Arrhenius, an acid is a substance that produces H plus ions in water and base is a substance that produces OH minus ion. According to Laurie Bronsted, an acid is a substance that donates H plus and a base is a substance that accepts H plus. For example, according to Laurie Bronsted, if I take an example of ammonia and HCl, when ammonia is treated with HCl, it forms ammonium ion plus Cl minus ion. If you look at ammonia, ammonia has accepted a proton from HCl and HCl has donated a proton. So HCl is a proton donor, hence it is an acid. Ammonia is a proton acceptor, hence it is a base. If you carefully examine the reverse reaction, ammonium ion has donated a proton to form ammonia. So in a reverse reaction, ammonium ion is an acid, Cl minus has accepted a proton, hence it is a base. Now, In this equation, ammonia is base, HCl is acid. In a reverse reaction, ammonium ion is acid and Cl minus is a base. Now, if you look at ammonia and ammonium ion, one is acid, the other one is a base. They only differ by a proton. A pair of acid and a base that differ by a proton are called as conjugate acid-base pair. If you carefully examine the conjugate acid, so the conjugate acid has one proton in excess, whereas a conjugate base has deficiency of one proton. That is, if they ask you to write the conjugate acid, so what you need to do is you need to add a proton and you should write it, because always a conjugate acid has one proton extra. If they ask you to write you the conjugate base, so what you should do is you should remove a proton. So to write the conjugate acid, we should add a proton. To write the conjugate base, we should remove a proton. Let's look at this. HCl, conjugate base of HCl is Cl minus. That is, after removing a proton, you get the conjugate base. Ammonia is a base, NH4 is its conjugate acid. So if you add a proton, you will get a conjugate acid. So conjugate acid, you should add a proton. Conjugate base, you should remove a proton. Now, another thing you should remember is, if the base is weak, then its conjugate acid will be strong. If the acid is strong, then its conjugate base will be weak. For example, HCl is a strong acid. If HCl is a strong acid, then Cl minus will be weaker in nature. Stronger the acid, weaker will be its conjugate base. Students, conjugate base of HNO3 is option A H2O, option B H3O plus, option C NO3 minus and option D none. As discussed, conjugate base, acid base, these are the pairs of acid and a base that differ by a proton. Conjugate acid can be obtained by adding a proton and conjugate base can be obtained by removing a proton. They have given us HNO3 and they have asked us to calculate the conjugate base. Conjugate base can be obtained by removing a proton. If you remove a proton, you get NO3 minus. Hence, NO3 minus is the conjugate base of HNO3. Therefore, option C is the right answer.
ಡಿಯರ್ ಫ್ರೆಂಡ್ಸ್, ನೀವು ದಿವಿಗೆ ಯೂಟ್ಯೂಬ್ ಚಾನಲ್ಗೆ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿ, ನಿಮ್ಮ ಫ್ರೆಂಡ್ಸ್ಗೂ ಹೇಳಿ, ಇದೇ ಥರ ನೂರಾರು ವೀಡಿಯೋಸನ್ನು ಫ್ರೀಯಾಗಿ ನೋಡಿ.